Okay, hello everyone, welcome. Can you hear me? Hello. Okay, thank you. Just we're waiting 1 minute, then we'll start with this session. Okay, so we will start with this session. So basically today is our second day. Okay. And I hope already all of you get the previous material, mainly practice code and also get all of other materials for the recorded session. Okay. So after completing the 3 hours live training, then we talk about the problem solving for the 1 hour. Okay. So in the problem solving class, you can simply share your own screen and then show me your own problem. Then we discuss about the solution. So before that, we just simply complete our 3 hours live training session. Then we discuss about the problem solving class. Okay, so let me share my screen. Okay, can you see my screen? Is it visible? Can you see? Okay, thank you. So let's get started. Okay, so basically we discuss about that filtering and displaying the satellite images, mainly how we can easily filter and displaying the satellite images, Landsat, Sentinel, MODIS, or any other satellite image, how we can easily filtering and display, discuss about that, and how to create the satellite composite. So different types of satellite composite, we also discuss about that, and how to use the different types of band combination, we also discuss about that. Then how to export the satellite images from Google Earth Engine, different types of satellite images, how we can easily export, we'll also discuss. And how to import, clip, reduce, and display the raster data in Google Earth Engine, we'll also discuss about that. And also discuss about the time series analysis for the different types of indices, we also discuss. And export the shapefile and also discuss about the annual image composite. Okay, we'll also discuss. Okay, and before that, okay, so we also discussed about the some basic concept about the remote sensing, basically how to remote sensing work, and this type of things I try to explain. Then anyone have no knowledge about the remote sensing, then I hope you can easily get the idea how the remote sensing work. These type of things we can easily get the idea. Okay, then we just jump the Google Earth Engine, how to connect the Google Earth Engine for the remote sensing analysis to get the different types of satellite imagery. Okay, so let's start. Okay, just okay. So after completing the class, I also send you some reference book for remote sensing related book. Then you also try to read the book. You can get the more better idea. Teach you some basic concept for the remote sensing. Okay, so mainly how it will work, what the sensor, what the resolution. So this type of things I simply discuss basic things about the remote sensing concept. Okay, so first of all, okay, I simply use this. So first of all, remote sensing, basically remote sensing is the science of obtaining information about the earth's surface without direction, without direct contact. Okay, sensor, it can be different types of sensor. It can be satellite, it can be aircraft or drone or balloons or ground based system. So without physical contact, we just gain the information. So remote sensing is one kind of science, okay, that obtaining the information about the earth's surface without physical touching. Without physical touching, we simply obtain the different types of information. Okay, so it can be forest information, land use, land cover information, water body information. So different types of information we simply gather without physical touch or without direct contact with the surface. So now how we can get the information in remote sensing, it's very important. So how I can get this type of information, or suppose I have some satellite, or I have some aircraft. So this type of satellites mainly give you the some information. It's called the EMR. Okay, EMR. So what is the EMR? EMR basically electromagnetic radiation reflected or emitted from the earth. So any kinds of satellite, Landsat, Sentinel, MODIS, or any kinds of satellites, basically it's give you the EMR. Basically this type of sensor, this type of satellite sensors measures the electromagnetic radiation or EMR. This electromagnetic radiation reflected or emitted from the earth surface. Okay, so basically from the satellite we can get the EMR, basically electromagnetic radiation, this type of values, and this type of values is stored at the different types of bands, suppose near infrared, red, blue. So we already check some bands after some time, thinking the idea. And EMR basically electromagnetic spectrum. Okay, it's called the EMS. So EMS range important for the remote sensing. Basically we are using the different types of range. Suppose if you check suppose I simply write EMS, electromagnetic spectrum, we find out the UV basically ultraviolet ray. UV, this range we find out 0.01 to 0.4, okay, 0.4 micrometer. Okay, then we find out that suppose visible range, we find out the 0.4 to 0.7, okay, micrometer. Then we also find out that NIR, near infrared. So this range we find out that 0.7 to 1.3 micrometer. Okay, then we find out the another, it's called the SWIR, short wave infrared one. We find out that 1.3 to 3 micrometer. And then we find out that another, suppose thermal TIR, okay, thermal infrared 3 to 14 micrometer. Okay, then microwave, this is the another. Basically in the microwave we find out the SAR imagery, it's called the microwave. This electromagnetic range we find out that less than 1 millimeter. Okay, So less than 1 millimeter, we find out. So each land cover types shows the different spectral signature across the bands. So different types of bands, we find out the different signature for a specific land use land cover. Suppose for the vegetation, we find out the specific range. Okay, suppose for the water body or barren land or build up, so every feature on the art, so each land cover type shows the different spectral signature across the different types of bands. And this is the range. And from the satellites, basically we find out that EMR, electromagnetic radiation, and this is the range, this type of range we find out. And now another information, it's called the platform and sensors. Okay, for the platform and sensor, this is another basic concept of remote sensing. It's called the platforms and sensors. So what is the platform? So basically in the remote sensing, we find out the three types of platform. Suppose ground based platform, then aerial and satellite. So most common, we are always use the satellite, but some other types work for the agriculture precision. We also use some drone imagery, also use some aircraft imagery, and also ground based, basically a spectroradiometer we also use for the ground based platform. So platforms, it can be three types. Suppose first type, it's called the ground based. Then another is, it's called the aerial, and finally last one is a satellite. So if you simply search on the Google, suppose I simply check the remote sensing platform, remote sensing platform, so if you check, you find out, so you can see the UVR drone based platform. Okay, then aerial, then spaceborne basically satellite. Okay, so you can see, we find out that three types of remote sensing platform. Okay, spaceborne basically it's a satellite. Okay, or airborne, it can be helicopter or airplane or drone. Okay, and ground based, you can see. So basically we are using that two types is most common in remote sensing. Basically spaceborne, basically satellite, and airborne basically drone imagery, or also air balloon or aeroplane. This type of imagery we are also used in the remote sensing. And then another thing is called the orbit. Okay, so orbit, we find out that basically two types of orbits. It's called the geostationary. So first type, it's called the geostationary. So this geostationary, basically it's a constant view. We find out the constant view, basically weather satellite, geostationary example. Then sun synchronize, we also find out for the pass the same time daily. Suppose Landsat Sentinel. Okay, this is another orbit types in remote sensing. Okay. And sensor type, so basically sensor, it can be two type. We find out the two types of sensor, and I will send you a book for that, then you can read, then you can get the all of information. So just I simply explain main concept of remote sensing. Okay, so we find out the two types of sensor. First type, it's called the basically it's called the passive sensors. In the passive sensors, it use the sunlight. Okay, so it's mainly use the sunlight, Example, Landsat or Sentinel. Okay, so this type of sensor, it's a passive sensor. And what is the active sensor? Active sensor, it emit their own signal. Suppose it just provide the light on signal and further gather the information. So it's called the active sensor. Active sensors emit their own signal. Okay, suppose it can be lidar. Okay, lidar is the one kind of example for active sensors. Okay, and finally resolution, it's very important in remote sensing. Suppose resolution, it can be four types. Okay, resolution, it can be four types: a spatial resolution, a spectral resolution, temporal resolution, and radiometric resolution we find out. So just to simply explain four types of resolution. So first type, it's called the spatial resolution. A spatial resolution. Okay, what is the spatial resolution? Spatial resolution, it's identify the pixel size. Okay, suppose pixel size. Okay, so suppose for the Landsat, we find out the pixel size. Suppose for the Sentinel to 10 meter, we find out Landsat 30 meter. Okay, then we find out that mode is 250 meter, and also 1 kilometer or 1000 meter we also find out. So it's called the pixel size. And pixel size, if you check this 10 meters, so when I use the 10-meter resolution, so then this image quality is more high. We find out that when you use the 1 kilometer, this image is not very high because pixel size is very high. If the pixel size is high, then we find out the low resolution. Okay, if the pixel size is low, then we find out the high resolution. Okay, so this is the pixel size, it's indicating about the spatial resolution. Then second, we also use the another resolution, it's called the spectral resolution. Okay, it's called the spectral resolution. A spectral resolution. The spectral resolution, basically number of bands. Okay, number of bands, how many bands you have in your satellite data. Suppose if you simply check Landsat, Sentinel, Modis. So if you simply search here, suppose Landsat, so I simply suppose Landsat, I just go to the link. If you check, suppose just open this Landsat 8 bands and band combination. If you check, we find out that this type of band for the Landsat: band 1, band 2, band 3, band 4, band 5, band 6, band 7, band 8, band 9, band 10, band 11. So this is the bands. So, and what is the spectral resolution? Spectral resolution, it's identify number of bands, how many bands in your satellite imagery or sensor, how many bands. So you can check, in this time we find out the total 11 bands for the Landsat 8. Okay, also left for the Landsat 7, you can see how many band. Only for the 8 bands we find out the for the Landsat 7. Okay, Landsat 5 and 4, you can see we also get this type of bands. Okay, so this is the spectral resolution. Basically it's indicating about the number of bands, how many bands in your imagery. And we can also consider, suppose RGB, so basically red, green, blue, it's one kind of bands. Suppose these 3 bands, not only, but some images we find out only for the 3 bands: RGB, red, green, and blue. Some image you also find out it's called the multi-spectral. Okay, multi-spectral image. Some image we find out that lot of bands, it's called the hyperspectral. So you also try to read this type of book I also send you, then get more better idea what is the multispectral, what is the hyperspectral. So if you check for the spectral resolution, it's counting how many bands in your imagery. So basically RGB, red, green, and blue. Suppose some images only have the 3 bands. So three bands are red, green, and blue. Some images have the multispectral, suppose red, green, blue, near infrared, short wave, infrared. If you check the Landsat imagery, have the lot of bands, red, green, blue. You can see visible band, okay, near infrared, short wave, infrared. So panchromatic, so a lot of bands we find out. So it's called the multispectral. Landsat, Sentinel, MODIS, it's one kind of the multispectral satellite imagery because there are the lot of bands. But when you work with some hyperspectral imagery, then we find out the lot of bands. Okay, lot of bands. So if you simply search here, suppose hyper spectral image. So this type of imagery, we find out the lot of bands information. Or if you simply search, suppose multispectral versus hyperspectral remote sensing. So then if you check, suppose this one. So you can see we can find out only for this type of bands for the multispectral imagery. But further in the hyperspectral imaging, it just also divided. Okay, all of bands. Suppose red, green, and blue. So this type of band is also divided in the hyperspectral. So now this type of imagery, it also give you the more better information than the multispectral. So that's the region for the mineral exploration or also others work. We also use the hyperspectral because there are the lot of bands, because we find out the more than 100 of bands in the one imagery. Okay, but for the multispectral only have the some red, green, blue, near infrared, short infrared. So this type of can we find out. So when you work with suppose some you want to identify some specific mineral or anything which is not very clear, so then we try to use the hyperspectral images to identify. Okay, so this is the spectral resolution in remote sensing based on how many bands in your images. So we find out that this type of band, multispectral, hyperspectral, and RGB, mainly only for the three bands some images also have. And another is very important, it's called the temporal resolution. Temporal resolution. So in the temporal resolution, what happened? In the temporal resolution, it's repeat time. Okay. Suppose for the same place, how much time I need to repeat. Suppose in the Dhaka city, I have an image in the 1st January. So now second image when I got for the Dhaka city. Suppose 5 days, 16 days. Okay. So we find out the different satellites have the different temporal resolution. Okay. Temporal resolution, it's mainly repeat time. Repeat time, how many days, suppose for the Landsat, Sentinel, how many days repeat time, okay, for the same place. So it's called the temporal resolution. And finally it's called the radiometric resolution. Radiometric then the radiometric resolution, basically it's information depth. Okay, it's called the information depth. Suppose some data, we find out that 8-bit information, 12-bit or 16-bit information. Basically these 4 types of resolution used in the remote sensing. Okay, spatial, spectral, temporal, and radiometric. And multispectral, hyperspectral, we already know about that. Suppose in the multispectral, we find out the band range. In the multispectral, we find out the band range, suppose 4 to 13 bands we find out. Okay, in the multispectral satellite imagery, Landsat, Sentinel, or planetoscope, this type of imagery. And hyperspectral, this range is 100 to 400 okay, or 400 plus, sometime 400 plus narrow bands we find out, narrow bands in the hyperspectral imagery. For the mineral mapping, vegetation biochemical analysis, or soil property estimation, we also use the hyperspectral remote sensing data. Okay, and data we can, oh, okay, so now how I can get the data? So suppose imagery, basically we can use the paid or free, both of images we can easily find out. Suppose data source, in remote sensing. So basically satellite data, how we can easily collect. So we can easily get the free source, suppose free, there is no need to charge for the free. Suppose we can easily use the Landsat, Sentinel. Okay, then we also use here the Modis. Okay, also we can use here the chart satellite data for rainfall, or ERA5 reanalysis, this type of data, or you can use SMAP for the soil moisture, or also hydrosheds. So there's a lot of data. Basically, all of data in the Google Earth Engine we can easily use the freely, not need to buy. So if you check the browse data catalog, it provides you with a lot of data, and this type of data you can easily use the freely, not need any kind of charge. Okay, but as well as we also use some paid data, paid or commercial imagery for the different purpose. Suppose I will show you that. Suppose paid we can use, it's called the planet scope. It's one kind of paid or commercial. Then world view, then Maxer we also use for commercial. Basically it's provide the high resolution, okay, high resolution imagery. We can also use, suppose quick bird. So this is another, or black sky, black sky. So this type of things, the paid version, basically it's provide you the more high resolution imagery you find out. Okay, and freely you can use this type of things. Okay, or all data set in the Google Earth Engine we can use the freely, not need to charge. And further, in the remote sensing we also use the, so step by step we work, no problem. So now, okay, any question for the remote sensing, for any concept you can ask me, I try to explain again. Any concept, if you don't any confusion, you can simply ask me, I try to explain again for the remote sensing basic concept. Any question?
I think you covered all the basics.
Yeah.
Thank you so much.
Yeah, please. Okay, so now get the practical example how we can work with the imagery in Google Earth Engine. Okay, so first of all, imagery for basically Landsat Sentinel. If you simply search, click on the browse data, then you can find out this type of website. So basically it provides you all of data catalog in Earth Engine platform. We can easily get all of data set. It's freely available, not need to charge. If you simply click on the Landsat, then we find out that all of Landsat image collection, you can see the Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So all of image collection you can easily get from here. If you click on the Modis, so then I find out all of Modis collection. Okay, different types of Modis collection you can find out in here. If you check the Sentinel, then I find out the all of Sentinel image collection in here. Okay, so when you work with any image collection, it can Landsat, Sentinel, Modis, all of image collection have the similar process when you work. Okay, so if you understand about the Sentinel Landsat, then you can easily apply the same process for the Sentinel or Modis, same. Because we already know about that image collection is one kind of data type in Earth Engine. Okay, so image collection is one kind of data type in Earth Engine. Image collection, it's one kind of data type in Earth Engine. If you simply search on the docs tab and find out the image collection data type, just find out the image collect, you can see image collection. Okay, so this is one kind of data type in Earth Engine. So if I click, then I find out all of those image collection related function. So this type of function I can only use in image collection data type. It can be Landsat image collection or Sentinel image collection or Modis image collection, whatever, no problem. This type of function I can use any kinds of image collection in Earth Engine. Okay, it can be Landsat, Sentinel, Modis. Okay, all of the same. So now I want to import a image collection in my code editor. So how I can import the image collection? So for that, simply find out. Suppose I want to work with Landsat. Click on here, Landsat. And if you check there, the lot of collection, basically this type of collection based on the time frame. Okay, you can see this image collection is available between this time period. This image collection is available between this time period. This image is available between this time period. So when you need the image, you try to find out the collection. Suppose I need the present time. So you can see Landsat 9, Landsat 8. Okay, so now, or suppose Landsat 9, just click on here. So now we find out this type of things. You can see surface reflectance and also top of atmospheric reflectance. Okay, this is the surface reflectance information. This is the atmosphere reflectance information. And this is the raw image. So basically in Google Earth Engine, we are using the surface reflectance and also use the top of atmosphere reflectance. So this type of surface reflectance and top of atmosphere reflectance is the pre-processed data. Okay, so this type of images already done. The atmospheric correction, okay, already done. So you don't need any kinds of correction or enhancement, not need, because this type, it's one kind of pre-processed image. Okay, it already done all of the correction. So now when you work with the Google Earth Engine, in this type of images, you not need any kinds of correction. Okay, suppose I want to work with the surface reflectance imagery. Just I click on here. So now if you check, I find out all of information about the image collection. This is the dataset availability time period. So this image collection is available between this time period. So last time you can see 2025 on 25 November. So this is the last time period. And dataset provider is the USGS. Okay, basically Earth Explorer, where you find out the data. So this is the dataset provider. And if you check the Earth Engine snippet ID, so this is the Earth Engine snippet ID. Every image collection, we find out this type of snippet ID. Okay, snippet ID is one kind of directory. Suppose this image collection is stored in the Earth Engine server. So in the server, which folder or what's the directory of this image collection? So this is the directory. It's one kind of folder directory of this image collection. So every image collection or every data set, we find out this type of Earth Engine snippet. So snippet work as a folder directory in the server. So if you check, it show the Landsat, then Landsat 9, then collection 2, tier 1, level 2. So this is the one kind of directory, mainly folder directory. So this snippet ID, we need to copy, just copy, and then paste in the code editor, just a paste. Okay. Then you can see this is the image collection. We already know it's one kind of data type. And this is the Landsat 9 image collection directory. Basically, when this directory is stored, the Landsat 9 image collection. So now these things, I need to store it in a folder. I need to create a variable. Basically, this variable, store it, this image collection. We already know about that, how we can easily create a variable. Before the variable name, just use the var keyword. Okay, then you can put any name as a variable. I put the name, suppose L9, then equal. So now what happened? So this is my image collection. This image collection, I just store it in this variable, and I put the variable name is the L9. You can put any name as a variable. So now I want to check how many images available in this collection. Okay, in this image collection, how many images are available, I want to compute. So for that, if you check, we need to use a function. This function called the size function. Okay, this is the function, size function. Just click on the size function, you can check what the description. So this size function returns the number of elements in the collection. Suppose in this image collection, how many images are available, we find out when I use this function size. Okay, and you can see this size function I can easily apply in the image collection, because if you check the subheading, this is the ae.image collection. Okay, so now all of function I can use for the different purpose, only for the image collection data type. So I want to use it. So for that I want to print, suppose how many images are available in this collection, and this collection I already store it in a variable. This variable name is L9. Just I copy the L9 and paste here, and then apply the size function. So now it's computing how many elements are available in this collection, or how many images are available in this collection. So now run the code and check what happened. Just run the code. Just run. So now computing number, how many images are available in this collection, we find out. So you can see, find out that this is the total number of image collection, and it's available for the whole world, globally, whole world. We find out this number of image collection, and what is the time frame. This time frame is that 2021 to present 2025. This time frame we find out how many images. This is the total number of images we find out. Okay, so this is my image collection. This image collection I need to filter. So how I can filter? So it's show the result for the whole world, mainly globally, all of scene, all of image, but I don't need for the whole world. I need, suppose, a specific boundary or a specific place. I need the image. So first condition for filtering, suppose it's called the where you need the image. This is the first question you can ask. Then it say the answer. Suppose I need the image for the Dhaka city or any specific place. So this is the first factor for filtering, where you need the image. Suppose I need the image for the Dhaka city. This image is available for the whole world, but I don't need for the whole world. I need the image only for the Dhaka city boundary or any specific area. This is the first factor for filtering. Second factor, how basically I need the image less than 1% cloud cover for my study area. Okay, so this is the another factor. Basically, suppose I need the image less than 1% cloud cover. I just need only for this type of image less than 1% cloud cover. So this is my another condition for filtering cloud cover. So this is the another condition for filtering. How I need that 1%, less than 1% cloud cover. Third factor, it's called the when you need the image. So this is the another, when you need the image for filtering. Suppose I need the image, suppose 2025 month of January. Suppose I need the image. So this is the three condition, basically where you need the image, how you need the image, and when you need the image. So where, how, and when just is filtering our image collection. So this image collection is the globally, okay, available between this time period 2021 to 2025. This time period we find out that all of images. So now this image collection is simply filtered. So if you just try to filter from 2025 month of January, I need the image less than 1% cloud cover, and I also need the image in the Dhaka city boundary. So these three conditions I need to apply for filtering. So first, where you need the image. So further you need to use a function. Okay, then how we need to use the another function, and then when we need to use another function. For the three filtering process, we need to use the three different function. And what types of function I need to use, we can easily find out under the docs tab. If you check it, suppose higher basically we are just use a function. It's called the filter bounds function. It's called the filter bounds function. So this function, filter bounds function, so how it will work, you can see shortcut to a filter a collection by intersection with a geometry. Suppose I have a Dhaka city boundary. This geometry, Dhaka city boundary. So this geometry I want to filter. Okay, how many images intersect with my study area? I want to filter it using this function, filter bounds function. Okay, so now we try to use it, filter bounds function. So for that I need to import the Dhaka city boundary in my shape file. So for that you can simply just click on the asset tab, and then just import the shape file. So here I already import the Dhaka city boundary shape file. If you check, where is it? And previous class I already discussed about that, how we can easily upload the shape file. So you also try to upload the own shape file, or if you want, you can also use the some data set is already available in the Google Earth engine. So you can also use this type of data. So here I already uploaded the Dhaka city boundary. So just I simply import it, show the table as a default variable name. You can put any name. Suppose I put the name is the ROI. So this ROI, this variable is stored at the Dhaka city boundary. Dhaka city boundary is stored in this variable. And where I need the image, I need the image Dhaka city. Okay, and Dhaka city is stored in the ROI. So let's go try to use the filter bounds function. So take a variable. Suppose I put the variable name is that filter. Suppose filter bounds. You can put any name, no problem. Then I call the L9. Basically, this variable is stored the large number of image collection. Just I call the L9 and then apply. Oh, sorry. Just I call the L9 because this is the variable name, and apply the filter bounds function. Filter bounds function. And if you check what's the argument of the filter bounds function, this argument is the geometry. Geometry mainly point, line, polygon. In this time, it's a Dhaka city polygon, mainly boundary. It's a polygon. And this polygon is stored at the ROI. So just I copy the ROI, this variable ROI, and then use here. So now what happened? So now this variable is stored how many images intersect with my geometry. How many images intersect with the boundary of Dhaka city? We find out. So let's check how many images. So same, just print this variable filter bounds and use the size function. So now it's computing how many images intersect only for Dhaka city boundary. So just run the code. So we find out that 156 images. We find out that 156 images in Dhaka city. We find out that it intersect with my boundary. And what's the time period? This time period is this time period, 2021 to 2025. So we are just applying the one factor for filtering. Okay, filtering for the where you need the image. Then how? Suppose from 156 images, I just need only for those images, which image will be not more than 1% cloud cover. So I have to filter image metadata. I want to filter image properties. So from 156 images, I just choose only for those images, which image will be not more than 1% cloud cover. So I want to filter the image properties or image metadata. So for that, we are just use the another function. If you check, it's called the filter metadata. And if you check some function is show this type of red color, it means that it's deprecated. But we can also use it. But if you check, click on here, you can see it's a deprecated, but you can use the filter earth engine filter equal or earth engine filter greater than equal. So you can also use this type of things. Use filter with this type of thing. So I'll show you the both of function. If you want, you can also use it. There is no problem. Or if you can also use this new function, you can see that also mentioned it's deprecated. Use filter with earth engine filter equal or earth engine filter greater than equal. But previous time you can see you can easily use filter, metadata, name, operator. It also still work. There is no problem. But you also try to use the new things. Okay, so let's try to both of things. How do we work? So first of all, filter metadata. If you check that the three argument name, operator, and value. Name basically image property name. Suppose cloud cover, it's one kind of image property. Not only for the cloud cover. If you check the image information, we find out a lot of property. You can see cloud cover land, okay, collection category. So there are a lot of image properties we find out. This is the image properties section. So first argument is the image name mainly image properties name. Then operator basically less than, greater than, equal. You can check the less than, equal, greater than, equal. So this type of operator. And value mainly number, less than 1%, 2%, 3%, this type of number. And it's written a collection. Suppose now from 156 images, I want to choose how many images are available less than 1% cloud cover. So this is my target. So further I simply use it. So for that, just take a new variable. Suppose I put a variable name is filter cloud, or you can put any name, and then call the filter bounds, because this 156 images store it in this variable. 156 images store it in this variable. Just I copy and then use the filter metadata function. Okay, so now first argument, if you check name belly image property name, if you check the image property name, cloud, suppose I use the cloud cover, just take copy the cloud cover and then paste here. Then operator I use here less than, and set the value 1. So now what happened? So now from 156 images, it just filter all of image which is the less than 1% cloud cover and store it in this variable. So now let's check how many images are available less than 1% cloud cover. Just print and call the filter cloud. Just copy and use here the size function. So now it's computing how many images are available in the Dhaka city less than 1% cloud cover. We find out 31. So these 31 images are available in the Dhaka city, and this 31 image is the less than 1% cloud cover. But what is the time period? This is the time period. Okay, this time period basically from 2021 to 2025, between this time period in Dhaka city, I find out 31 images is the less than 1% cloud cover. But I don't need for the whole time period. I need for the specific time or a specific year or a specific season. So I need the image. So for that, we also use the another function. It's called the filter date function. Filter date function. So start and end. So simply define the start date and end date. So you can see shortcut to a filter collection by date range. So I have 31 images. Okay, but I want to filter this image only for the month of January 2025, or summer season or rainy season or any specific time period I want to filter. So let's go ahead to filter. So take a variable, suppose filter date. So from 31 images, and this 31 image is stored in this variable. Just I call the filter cloud and apply the function filter date function. Okay, date function, and define the time. Suppose 2025 1st January, from 2025, suppose I just put here 05, so 30. So this is my time period. You can put any month or any season, no problem. So now let's check between this time how many images are available. Just print and filter date and apply the size function. So now computing how many images are available less than 1% cloud cover in Dhaka city between the time period. We find out only for the 4 images. Okay, so if you check first time, we find out the very large number of image collection. We simply filter it for our study area. Then we filter cloud cover, how many less than 1% cloud cover. Then we filter a specific time period. So any image collection, not only for that, any image collection, it can be Landsat, Sentinel, Modis, any kinds of image collection. We are just applying this process and filtering for our study area for a specific time period, or choose a specific image properties. Okay, so you can see basically you can simply filter bounds function, filter metadata function, and filter date function. So filter bounds function, where you need the image, basically Dhaka city boundary, and Dhaka city boundary already stored in the ROI. Okay, then filter metadata function, it's mainly work for that image properties, and we choose the cloud cover less than 1. But this function, if you check, suppose I want to use the another method, because you can see it show the red color, really deprecated. We also use this type, use filter earth engine filter equal or greater than. So we can also use this type of things. If you check, suppose I just change the function, or I just comment it, just a comment. So I try to show the another way. Suppose take a variable, I put the same variable, suppose filter cloud equal, I just call the filter bounds, and then apply dot filter. Okay, and then put art engine filter dot less than. Okay, less than. So now I assign the value, suppose cloud cover, and then comma put the value 1. So we can also use this type of things, no problem. Same, we find out the same result. If I print the filter cloud and use the size function, we find out the same number of images. That is no problem. Okay, we can add that 31. Okay, so but if you can also use the filter metadata function, no problem, it also works. I think after some future time this function will be removed from here, from the docs tab, and further we can also use only for this function. Okay, filter art engine filter less than. Okay, because you can see it show the red color. Not only for that, we also get some other function also. Previous time this type of function is also work, but it also work, but I think in the future it will be gone. Then we can get only for this use this type of function, filter art engine filter that less than. Okay, same, we find out the same number of images, no problem. Okay, so now final, how much image we find out? The 4 images, mainly 4 scene we find out. So I want to check all of information about this 4 images, mainly acquisition date, and this 4 images is not captured at the same time. Okay, between this time period, at the same time it's not capturing. It captured the different time or different date in this time period. So I want to check all of date, all of information. So let's go. So for that, just use print function and call the filter date and run the code. Just run the code. So then you can see, find out that image collection. Okay, click on this here, you can see the type is one kind of data type. So this type is the image collection. Image collection basically set of images, and we find out the total 4 images, 4 elements, mainly 4 images. If you check all of information about the image, this is the first image. Okay, 0 mainly first, then second, third, fourth, total 4 images we find out. So click on here and then check, you can see total 19 bands we find out. And if you check all of properties, you can see the cloud cover level, cloud cover land, then collection tier 1, collection number 2. So all of information find out for this image, and this is the image acquisition time, 2025 16 February. Okay, this is the first image. Suppose I want to check this image, click on here, click on the properties. So now you can check all of information. This is the cloud cover, and this is the image acquisition time. You can see 2025 4th March image acquisition time. So all of information you can really check it from the image. So now you can see, find out the image, total 4 images in this collection. Okay, and when I click in the 0, you can see it show the type. So type is the image type, so it's the image. Okay, so single image. Click on here, you find out the image, it's a image type. Suppose now I want to visualize this type of image in my map. I want to visualize. So for that, if you simply check the image data type, how to visualize the image, just find out, you can see the another data type, ee.image. Just open, you can see the first function, ee.image args. So basically it's indicating about the directory or id. If you check an object to represent an earth engine image data type, and you can see this, it can be a string earth engine asset id, or string and number and earth engine asset id and version. So we are just simply define the id. Okay, suppose I want to display the first image, so I need to identify first image id. And where I can get the id, if you check, click on here, it show the id. You can see every image show the id, different id. So this is the id, this is the id, this is the id. Suppose I want to work with just this image, third number image. So just I copy the id. Okay, just I copy the image id. Okay, just I click on here, this is the id. Okay, just I copy this id, just copy this id. After copy this id, just use a function ee.image. Okay, this is the function ee.image, and then you can, this function is simply use an args, mainly directory or id. So this id just paste. Okay, so now what's happened? So now this image we simply import in the code editor. Okay, and now this whole thing just store it in a variable. Before the variable name, use the var keyword and put the any name. I put the name, suppose image. So now what's happened? So now this image is stored in this variable image. Okay, suppose you want to work with for the second image, just simply copy, the id. Just a minute. Just simply copy the id of the image. Okay, you can see every image have the individual id. Just copy the id and then paste, then you can easily work with this image. So this image I want to visualize on my map. So how I can visualize? You already know about that. We need to add the layer. Okay, so simply use here map.add layer. I want to add the layer for this image. Just I copy the variable, because this variable is stored the image, and then paste here and run the code. So now you can see it's a loaded layer, but not focus on my given study area. So I want to focus on my given study area. So for that we already use map.center object function to visualize or focusing on our given study area. Map.center object is ROI, mainly my shape file I want to focus, and then zoom level I put suppose 10 and run the code. So now we directly focus on my given study area in Dhaka city boundary, and you can see it also loaded the image. So we find out this type of tiles or scene. Okay, it shows this type of tiles or scene. Okay, and this acquisition time, if you check, this is the acquisition time, 16 February 2025. This image acquisition time. So it look like that. This is the image tiles, and this tiles is overlay with my Dhaka city boundary. If you check it, it's overlay or not. So for that, simply add the layer, map.add layer of your study area, mainly shape file or geometry ROI. So now run the code. Now two layer is added. So first layer is added for the image, second layer is added for satellite image. You can see. So you can see it's properly overlay with my study area. So this is my study area, and this tiles is overlay. Sometimes we face some problem. Suppose my study area is much big. Suppose my study is very big. I need the image for the whole country boundary of Bangladesh. Suppose I work for the whole country boundary of Bangladesh. Then one tiles is not enough. The one tiles is not enough. So then we just apply the another process. So I'll show you this after some time. Then you can get the idea how to work with the biggest area. We can easily find out the single date image. Single date image is the just overlay with our study area of Dhaka city boundary. So now I just need the image only for this boundary. Other side I don't need. Just use the clip function. Okay. If you check clip function in the image section, if you check the where is the clip function? Clip. This is the clip. You can see the clip function. Clip function you can only use for the image data type. Okay, because you can see clip function, clips and image. Okay, only for the image data type. And this is my image. This is my single image. So I can easily use the clip function. But when you work with the image collection and you try to use the clip function, then it creates some problem. It not work. Because this data set, if you check the subheading, this heading is ee.image section. You can see ee.image section. So this all of function I can only use for the image data type, and this is my image. Okay, this is my image. So I can easily use the clip function. And what is the argument about the clip? If you check, the argument is geometry. Geometry mainly point, line, polygon. So in this case, my geometry is the Dhaka city boundary, and I already stored it in the ROI. So just use the clip function and define the ROI. So just I use dot clip function, dot clip with study area mainly ROI. So now if I run the code, what happened? You can see we can get the image only for my given study area of Dhaka city boundary. So we find out, but it look this type of dark color. because we are not adding the band combination. Okay, so now we talk about the band combination, how to use band combination. For combination is one kind of technique to identify different types of feature from the surface. Okay, so if you simply check my previous link where I discuss about the bands and this type of things. So if you check, we are use the different types of band combination for identify different types of feature from satellite imagery. So if you check this, it's called the natural color. Okay, natural color. Basically band 4, 3, 2, basically red, green and blue. So when I apply the red, green and blue, what happened? It show the natural color. Okay, basically naturally human eyes can see healthy vegetation is green, unhealthy flora is the brown, urban feature appear as the white and gray, water is the blue, dark blue or black. We find out. So I'm going to apply this band combination in my image and then try to visualize. So let's go. For that, how I can add the band combination in this image. So for that, just click on the layer. So basically this is my image layer. So this layer extruded the image and this layer extruded the layer. So I want to add the visualization for the image layer. Just click on the setting layer properties. And further, if you just add, suppose I want to add the band 4, red, then green and blue. Now we need to stress our data. Okay, stress basically it's one kind of visualization process. If you check different types of stressing level, 1 sigma, 2 sigma, 3 sigma, 90%, 80%, 100%. Suppose I just keep 98% stressing level, then you can check what happened. And if you check, it show a very large number, 8,716. Basically it show the digital number. It's not showing the reflectance value, because we already discussed about that different range of the reflectance value. But if in this case we can see, we find out this type of range, 8,000, 14,000, very high number we find out, because in Google Earth Engine digital number, okay, it provide the digital number reflectance value. But this type of reflectance value we can also use the scale value and also use the offset value to get the proper wavelength value or proper EMR value. Okay, so when you are using the scale value and offset value, it provide you the proper wavelength value. Then we find out this type of range. Otherwise you can see it show very high, 14,000, 6,000. So now how I can use this type of scale value and offset value in my image? So basically this scale value we need to multiply, and this offset value we need to add value. Okay, same scale value and offset value, all of bands are the same scale value and offset value. So just we simply copy the scale value, and then this is my image, and I simply use our multiply function, multiply, and then add with offset value. Where is the offset? You can see the dataset information, offset value, just copy the offset value. So now this digital number convert into reflectance value, just I paste here. So now if I run the code, so now I can add the band combination for this layer. Just click on here and I add suppose red, then green and blue. Stressing I keep 98%. So now I can see find out this type of range. Otherwise it show very high digital number, but when I simply multiply and add the scale value offset, then it provide the range. So I put the red, green and blue. It's called the RGB. Okay, natural color. Just apply. So now you find out this type of natural color view for the satellite imagery. Okay, and it's a single date imagery. So you can check this is the, so you can simply click on here, you can see the browse data catalog. Okay, then you can easily find out the data catalog information. Okay, just click on the browse data catalog and then you can see the land set. Click on the land set. Okay, then you can easily find out that image collection, all of land set, sentinel mode, Swiss unit, simply work. Okay, from the browse data catalog. Okay, so now you find out, you can see this type of imagery. So this is the natural color image collection we find out. So we can easily find out from the visualization, this type of green color is the vegetation. We find out this type of place is the build up or urban. Okay, we find out this type of place is the barren land, or this is the lake of water body. So naturally view we find out. And when I import, you can see this visualization is not import in my code editor. So this visualization I need to import. So how I can import? Just click on the import button. So now you can see it's imported and put the variable name is the image. So just I copy the variable name, and this visualization I set with this layer. So for that, just copy the variable name and paste after the object name, paste here. So now this image set this visualization. So now this image I set this visualization. So now further when I run the code, we find out the same visualization, mainly natural color. We find out this type of visualization. And if you want it show the layer 1 default name. Suppose I put the layer name. So for that, just use the comma sign and put the layer name. Suppose I put the layer name is that natural color. So now it display this type of layer name. Natural color. We find out. Not only for that, suppose I want to add the another band combination. Mainly 3 bands make you 1 combination if you check. So we are just applying that. It's called the color infrared. So it's called the 543. Mainly near infrared, red and green. So when you are using this band combination, we find out the vegetation show as a red color. Okay, vegetation show as a red color, and water body show as a dark color, urban feature as a white color. So we find out this type of things. So this, suppose I want to apply this band combination. So same process, just click on the image layer. So I want to apply near infrared, then red and green. Put this stressing, suppose I keep 98% for stressing my images. So now apply. So now you find out the another band combination. In this band combination, you can easily find out this type of green color, it's a vegetation. Okay, this type of black color, it's a water body. Okay, this type of black color is the water body, it's a water body. And this type of green color, it's red color, it's a vegetation area, we find out. As well as this type of gray color, it's a barren land, we can easily identify. Okay, this type of, it's a vegetation, red color. Okay, this is the water body. So this is one kind of band combination. So this band combination I want to import in my code editor, and I want to add the layer for this. So same process, just I click on the import button, you can check, just click on the import, a new line of code will be added in here. So now I'm going to add the layer for this visualization. So same, just I copy the same line of code, map.add layer, and then paste here, and just change the variable name. I put the variable name, this is the variable name, because this variable stored this band combination. And I put the layer name, suppose color infrared. So now run the code. So now I can see it's added the 2 layer, difference to band combination. You find out color infrared and also natural color. So this is the first band combination you just try to add, and this is second natural color. So now further you can also compare, just more zoom. So green is the vegetation, but when I open the layer, red is the vegetation. Okay, you can see this type of green color show as a red for vegetation, and water body show as a black color and dark color, we find out. And see, we find out this type of place is the urban or white color, we find out. Okay, this type of place. Also this type of place is the build up. This is the build up, this type of place. Okay, build up. Okay, so now suppose I add the another band combination. So this is the short wave infrared. This is another combination. This is the another, you can see 652, mainly short wave infrared 1, near infrared and blue. So it's very helpful to identify agricultural land and vegetation. We can easily identify. If you check this image, we find out the agricultural land have a pattern, a square shape or rectangle shape. But when you can see vegetation, we find out this type of pattern. Okay, but for the agriculture, we find out this type of a square shape. So let's go try to use it. 652. So same. Just I click on here. 6, 5, and 2. It's tracing on 98%. And further just apply. So now you find out this type of visualization. So it's also very helpful to identify vegetation, agricultural land, water body, then barren land. Okay, barren land we can easily identify. So I discuss more details when I just talk about the land use, land cover classification. Then you can get the more better idea. So just I import the visualization. So same process, just I click on the import button. You can see the import button, just click. So now if you check, it's added the new visualization information. So this thing just I copy, or just I copy the same line of code and paste here and change the variable name for this visualization, and then add the layer name. I put the layer name, suppose vegetation. You can put any name as a layer. Now run the code. So now you find out this type of 4 layer. So first layer is our study area, mainly shape file. Then we just add 3 different band combination for the same images: vegetation, color infrared, and natural color. So not only for that, you also search different types of scientific paper. Lot of band combination is available, and this type of band combination mainly help you to identify different types of feature from satellite images. Not only for that, we also use some other indices. So further we also discuss inshallah one by one, then you can get the more better idea how to use different types of indices to detect the different types of feature from satellite imagery. We also discuss about that. So now any question about that, you can ask me, please. Any question for single date imagery?
Hi, Vijay.
Yeah,
This
please.
is it. Is there any way you can provide maybe like a document with algorithm, like with this code, like first you do this, second you do this, and third you do this, like in terms of code
Mainly
to acquire the images?
okay, I will provide some PDF also about that, and I also send you this type of code link. So every code I try to add the comment. When you read this type of comment, you can also get some document also. Inshallah, I send you this type of document.
Thank you. Thank you.
No problem.
Thank you.
Yeah. Okay, so this is the process for
So,
yeah, please.
sorry, will you be able to share with everyone?
Which one?
Will you be able to share the documents you're talking about with everyone?
Yeah, everyone, you can, I share it in our Google Classroom. You can easily get all of those document, all of PDF, everything, all of it, no problem. Yes, please.
When you wanted to do the image visualization, you use the imported data from the assets. Is there a way you can use data sets from maybe like US JAWS or file that you show the method? I don't know whether you get my question.
Okay, so you asked me about that, how we can easily import the data from the asset. Yeah.
I'm saying, is there a way maybe you can do the visualization from data sets from maybe FAO or FAO or US DOS like you showed in the last meeting?
Yes. Same. So I'll show you the example. Simply search USDOS. So now again, so you find out that or FAO, suppose small area, suppose FAO for the second level. Suppose from here I simply take the study area, mainly shape file. Suppose I simply import the second level administrative area. It's importing as a table. Okay. And further, I simply choose my study area. So take a variable. Suppose I put the variable name is ROI. And I remove my previous ROI, which I uploaded from my asset. Just I remove it. So this table I want to filter. So just use the table and filter art engine dot filter dot equal. So now what's equal what? Just I put the column name from this. You can see the, suppose I want to use the administrative level 2, just I copy. Okay, so this is administrative level 2, and further I want to use it in here and paste and then put the name. So I put the name for Dhaka. So now what happened? So from the FAO, I just collect my Dhaka district boundary. Okay, and instead of the ROI and other keep the same. Okay, so now run the code. So now I can get the result for Dhaka district boundary. So now if you check, we find out this type of result. But I work with the Dhaka city, so Dhaka city is not available for this FAO. So just I simply import the Dhaka city boundary in my asset tab and import in my code editor. But we can use it. You can the Dhaka city district boundary, find out this type of things just from the FAO dataset, mainly administrative level 2 data, so you can find out. Okay. So not only for that, any district can simply search, then you can get the result. But it also creates another problem. Suppose in this case, I simply change the another district, suppose for select. Then you can say it create a problem. It show a wrong. It show a problem. You can check. It show select there is no image. You can say it show there is no image, because if you check in here, I already paste the ID. This ID is only for Dhaka city boundary when I filter. Okay, when I filter Dhaka city boundary, then I get this type of ID. So now when I work with the another city, then I need to filter the image collection again. Okay, and then you can see it create the another new, also find the same for image also. So just I copy from these images. Suppose I just copy this image ID. Just I copy, because first ID, this ID I generate only for the Dhaka city boundary, but now I simply change. I put the select. It's another area of interest. So just I copy the ID and then change the ID level again. Just I change my previous ID. And now run the code. Now check what happened. So now you find out the image for this area. Okay, so you also careful about that, because some you are just filtering the image collection for the Dhaka city boundary, but you try to work for the another area of interest, so then it will be not work. So you need to copy the ID again, and then change the ID, then we can get the image. And this is the image. We find out this is the image acquisition time 25 February, okay, for this area of interest. So we find out this type of things. So now we can use it for making the land use, land cover, vegetation analysis, water body analysis, or land use, land cover. So anything we can do for this using this imagery. Okay, we find out this type of imagery. Yeah. Okay, please again. Any question? Yes, please.
Oh, okay. I'm interested in the land use, land cover.
Yeah, we try to cover.
Visualization.
We try to cover all of those step by step. So basically we already published our syllabus course content. Okay, so this land use, land cover, we try to discuss about that 6 number days. Okay, so today is our second days. So step by step, I think it will complete all of those, and you can easily learn all of those from basic to advanced level, inshallah. No problem. Okay, so now you can easily get this type of imagery, but in this case I just work only for the small area or a small district, but I need the image suppose for the whole country boundary of Bangladesh. Okay, then one tiles or one image is not enough when I work with the whole country boundary of Bangladesh. Okay, then I need to combine the tiles, combine the all of images, and it's called the composite. Okay, I need to create the image composite when I work with the big study area. Okay, if you simply search on the Google, suppose for Bangladesh perspective, suppose Bangladesh satellite tiles. Okay, let me open okay, so if you check the first image, so you can see when you work with the full country boundary of Bangladesh, so I need the not only for the one tiles, you can say I need the 1 2 3 4 5 6 7 8 9 10 11 12 13 14 or 15 scene. I need to combine, I need to merge when I work with the full Bangladesh boundary. Okay, so but when you work with for the small study area, suppose district or also village or union or any small study area, then we can easily work for this type of tiles, single tiles we can easily use, and then we can easily work. But I need the image for the whole country boundary of Bangladesh at the same time. Suppose in 2025 I need the image for the whole country boundary of Bangladesh, then single tiles is not enough, then we need to merge multiple tiles or multiple images. I need to merge, and how I can merge? So it's called the composite. And composite, it can be different types. So let's get ready to discuss about that, how we can work with for the big study area. A small study area we can also use the composite, but it's not neat for the small study area. Okay, suppose you can see here in this case I find out the total 4 images. Okay, I find out the 4 images, so I am not using all of images, I just use only for the single date imagery. Okay, from the 4 images I just use only for the single date imagery. So it's called the single date imagery process. Single date, how we can easily get the image single date only for the specific date. Okay, if you want you can combine all of images and create the composite also for this area. Okay, but for the small study area it's not neat, but when you work with the big study area then we need for the composite concept, otherwise it's not neat. And we also get some benefit when you are using the composite, because then all of image just make the merge, we find out the more better information when you just apply the composite of images. So let's we try to discuss about that, how to work with composite in remote sensing. And what's the benefit to use the image composite? Okay, So image composite. So what is the image composite? Image composite is one of the most important pre-processing step. Basically, it's help you to remove the cloud. So first, image composite help you to remove the clouds. So this is the first important things. Remove the clouds. Not only for the clouds, it also remove the image noise. Okay, noisy pixel will be removed. And then also we find out the basically it's remove the cloud or cloud free noise or other unnecessary pixel will be removed from here. Okay, so this is the one benefit to use the image composite. Suppose you want to work with any place, there are almost cloud formation. Suppose for the river bank or coastal area, in the river bank or coastal area we find out the all time we find out the cloud. And then when we apply the composite, suppose in the coastal area we find out the 4 images and all of images have the cloud. So then you can simply apply the image composite and then you can easily work with that. Then we find out the neat and clean satellite imagery. So image composite is the result of combining multiple satellite images. Okay, where you use the multiple satellite images into one final image based on median, based on minimum, based on maximum. Okay, so basically median is very helpful. Sometimes also use the mean or minimum or maximum. Suppose now I have total 4 images. So now how I can compose it? Suppose I just computed all of images average pixel value and then create the single average composite image. Or from the all of images, I just create the median pixel value and create the one median image. Or from all of images, I create the minimum pixel value and compute the minimum composite image, same like as maximum. Okay, so this is the way. Suppose we find out the remove cloud and noise. Second, we also find out that remove fill gap. It's important, fill gaps. Sometime we also find out some images have some gap. Okay, suppose dotted line, or we find out the gap. Suppose some images, so now there is no gap or there is no things. Okay, it's also okay, but sometimes you also face this type of problem. Your image have some gap. So then when you are using the median composite or image composite, then this type of composite fill this pixel. Okay, so then it's just gap fill up. It also help you when you apply the image composite. Then improve the classification accuracy. It's very important. So basically when you are using the suppose land cover classification, try to use the image composite. It's improve the classification accuracy. We also use this type of things, and it also help you to create seasonal and annual maps. Okay, suppose seasonal annual maps, suppose NDVI, annual NDVI. Okay, or wet season composite, dry season composite. So further also discuss about this type of things, how to create the annual image composite or dry season image composite or rainy season image composite. Then you can most. So now this is these types of composite we also use. Okay, it's called it's a types of composite. Okay. Types of composite. So first type is mean composite, median composite, maximum composite, minimum composite. So in the median composite, it's most common use. Okay, we are used a lot of time. Basically, it's very helpful. It's the most common between the 4. Okay, and it's help you to remove the cloud and also extreme values. Best for the Landsat Sentinel, we use the median because median filters out bright cloud and also dark shadow. Okay, so this median composite it's remove or filter bright cloud and also dark shadow will be removed when I apply the median composite. Okay, And also mean composite, it also helpful. Sometimes also use some mean composite, useful for long term average. Okay, suppose climate or land cover, use the mean composite, useful for the long term average. Suppose I want to compute a long term annual average precipitation or annual average land surface temperature. So this type of things we also use the mean, or suppose mean NDVI. Okay, suppose annual average NDVI. Okay, then we try to use the mean. Okay, and maximum, suppose high NDVI values represent the peak greenness. Suppose sometime I want to apply suppose maximum, it's one kind of composite. This composite, it's great work for the vegetation. Suppose I want to identify high NDVI values using the maximum. So high NDVI values, it represent the peak greenness. Peak greenness we can easily identify. And also minimum composite, suppose great for the water detection. Okay, so water is darkest feature, so we can use the minimum composite sometime to identify for the water detection. And for the healthy vegetation or peak greenness, we are using the maximum composite. So this type of thing also use. So now how I can apply? Okay, so let's go for the big study area. Suppose I want to import the another shapefile from US. I take the large international country boundary polygon 2. It's stored in the table 2. This table 2 I want to filter and choose my country. Okay, specific country boundary. So just take a variable. Suppose I put the variable name is BD. Okay, equal. Call the table 2, because table 2 is stored the large scale international boundary polygon. So this table 2 I want to filter. So how I can filter? Earth engine dot filter dot equal. So what equal what? I put the country name and choose the country name. Suppose I need the result for Bangladesh. Okay, so now I just simply stored my Bangladesh boundary, mainly polygon. I just simply import the Bangladesh boundary polygon. So this polygon I want to filter and display the image. So same, I need to apply the same concept. All of those are the same. Okay, same concept. So let's go try to write the code for filtering. The same concept we also use. Suppose I take a variable. Suppose I put the variable name is image BD, and I call the satellite image L9. So it is stored the Landsat 9 image collection. I just paste here, and then I apply the filter bounds function with my study area. So in this case my study area is the BD, mainly Bangladesh boundary, whole country boundary of Bangladesh, and paste here. So now if you want, you can take the another variable and filter, but if you want, you can also take the, just put the dot notation and use the another function. Suppose filter, then earth engine dot filter less than, I put the cloud cover and set the value 1. Okay, so now I am filtering the cloud cover, then put the filter date. So I put the filter date, suppose year of 2025, suppose 1st January from 2025, suppose 10:30. So you can put any time. So now you can say what happened. So in this case, I just take only for the one variable, and under this variable I just put 3 different function. Okay, but previous time you can see when I write the code step by step for your understanding, I use the, for this variable I take a new variable, I take for this variable, for this function I take the another variable. So for this function I just took the another variable, but now I just take the only for the one variable, and under this variable I put all of function under this variable. Okay, so it also works, there is no problem. So now if you check how many images I find out after filtering all of those, just I copy the image BD and use the size function. So now it's computing how many images if you check after final filter. we find out the total 41 images. Okay, we find out the total 41 images. So this 41 images is available between this time. Okay, this 41 image is the less than 1% cloud cover, and this 41 image is the intersect with my whole international mainly boundary, Bangladesh boundary, BD. So this 41 image I want to use and then make the median composite. Okay, I want to make the median composite. So now I apply, and if you check here the function, so it's the image collection. 41 is the image collection. And now if you check the image collection, we find out a one function. This is the image collection. Click on here and now find out the function of median. Click on the median. So you can see median, it reduces an image collection by calculating the median of all values at each pixel across the stack of all missing bands. So now I have total 41 images. This is my image collection. So it's calculating the median of all values at each pixel across the stack of all missing bands, and bands are matched by their name. Okay, so now when I apply the median, and it create the median composite of this image. So for that, just I apply here dot median. Okay, so now if you check, now when I run the code, it show a problem. Just run the code, it show a problem. We find out, we can see, we find out this type of problem. It show the size is not a function. It show the size is not a function, because anyone can guess it why it show this type of problem, or what the wrong in this code. Anyone can get it? Okay, it show a problem because when I apply the median function, then this variable is not a collection. So when I apply the median, this variable just a image, single median composite image, and size function is only work for the collection. Okay, this function, this size function is only work for the collection. But when I apply the median, this variable just convert into a single median composite image. So that's why it show size is not a function, because size is only work for the collection. But when I apply the median, then it's not a collection, it just convert into a image. But you can say without median it work, there is no problem. Okay, so without median it's just a collection, image collection. But when I apply the median, this 41 images convert into median composite, single median composite image. So you can see when I just apply the median, it show a problem, because size is not work for image data type. Size is only work for image collection. But when I apply the median, it just convert into single median composite image. So that's how you find out this type of problem. Okay, suppose some function, we not only for that, lot of time we also find this type of problem, because this function is for image collection data type, but I want to use it for the image. We face this type of problem, then we face this type of wrong or error message we find out. Okay, it means that size is only work for the collection, but I just apply it for the image, and when I apply the median, it's just convert into image. Okay, I hope you can got it, the idea. So now without size, you can see, just on the code, it show a single image, single median composite image, just for the single median composite image. And this image have 19 bands. If you check, it just create the single median composite image. Okay, so this image I want to visualize in my map. Same process, just add the layer, map.add layer, and call the image BD and run the code. So now if you check, it added another layer for the whole country boundary of Bangladesh. So we find out this type of image, as you can see. But if you check, it's create the full. Okay, so now we try to clip and then check what happened. Just we try to clip. So you can see it's a image. Okay, so when I apply the median, then I can easily apply the clip function. Okay, so clip with my geometry, and geometry is the BD. Okay, so now run the code. BD means Bangladesh boundary. Now we can guess this type of problem. You can see some part of Bangladesh is missing. It show this part is missing. Okay, because this type of place, it don't find the less than 1% cloud cover image. Suppose this type of place or this type of place, less than 1% image is not available, so that's why it creates this type of problem. So now how I can solve it? So for that we need to increase the cloud level. Okay, suppose in this time I just take the less than 1%. Suppose I just consider less than 3%, then check what happened, it's the flop or not. So now check it. Not only for this case, some study area in the river bank coastal area, you face the zero image. Suppose you try less than 1%, but there is no image for the less than 1%. Then we find out the zero. It shows the zero number. So then you just simply increase the cloud level, then we find out the image. So now let's check what happened. It is still not fill up. So we try to put suppose cloud cover less than 5. Okay, lower fill up, but this part is not fill up. Okay, so still we need to increase the cloud level again. That was I put the 10. So now let's check. Or increase suppose 20. So we find out the whole country boundary of Bangladesh. It creates. So now I want to add the visualization. So same process, just find out the layer. I think this layer, yeah. So I want to add the visualization, same process, just click on here. And you can see it show the digital number. So we need to convert the reflectance value. So for that, simply add here dot multiply with the scale value, and also add with offset value. And you can check the scale value from this image information sheet. So this is the scale value, just a copy and then paste here. So now we find out the proper wavelength value. And further, if you just add the band combination, suppose I add the short wave infrared one, near infrared and blue, stressing 98%, and then further apply. So now you find out this type of band combination or this type of images for the whole country boundary of Bangladesh. Okay, so now further we can simply use the different types of remote sensing analysis. Suppose land use, land cover, or LST, or vegetation analysis, or crop types mapping. So different types of things we can do from this type of satellite imagery. And this is the process for when you work with the big study area. Okay, we need to create the composite, but it also possible we can also use the composite also for the small study area, same process. Okay, but you can see when I work with for that, I just simply take the single imagery. But if you want, you can also use the composite image also, same process. Okay, just one function, then we can easily create the composite, but in this time it is a single net. So basically these two types of imagery we also use in the remote sensing. A small study area, for we can easily get the single net imagery. For when you work with the big study area, suppose this type of study area is not covered for the single tiles, then we try to combine multiple images and then work. Okay, any question please? Okay, I got the idea. And this type of image we can also export. Okay, suppose I want to export this type of satellite imagery, and further I can also work with the other geospatial software. Okay, it also possible we can also export it, this type of imagery, and further we can also use the ArcMap, QGIS software, okay, or NV software we can also use for the different types of remote sensing analysis.
When you will export the images, you will export them as GATIF images
GeoTIFF,
or KML format.
GeoTIFF. We find out the GeoTIFF format, raster format, GeoTIFF, and further we also use it the ArcMap or QGIS software. We can get it. Yes, please, please. Yes, any question, please?
I wanted to know if when you are doing the exporting, does the image come with all the bands?
All the bands, yeah, all the bands you find out, no problem. Or if you want, you can also select some specific bands. It also possible. Suppose I simply choose a specific bands only for suppose I just export only for the 7 bands or any specific bands. We can also just choose, and I will show you that after some time. Just a minute for exporting.
Or
Okay. Okay. So now you also try. So now I'll also give some assignment. You also try the same process with the Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. You also try to use all of collection because similar process. Okay. You also try. So I also give some assignment regarding this type of topic, but you also try for the Landsat 8, Landsat 7, Landsat 5, Landsat 4, and Landsat for the different time. Okay, you can see this image collection is available between this time. This image collection is available between this time. This image collection is available between this time. Okay, for the different time, because when you work with historical data analysis, we need this type of historical image collection. Okay, and Landsat is available from 1972, but some place is the missing, but maximum we find out. But also some place have the limitation for this 1972. But 1984 or 85, we can get all of places. This type of imagery for the Landsat is available. Okay. So now you talk about the another section. So you also try to practice this type of imagery for filtering, visualizing for your own study area. Further, any problem, also discuss about that. So now we discuss about the MODIS, how we can work with the MODIS satellite data. So basically MODIS, it's provides some ready-made product. Okay, mainly ready-made data we find out from the MODIS. I can say daily product. It's the daily. Mainly we find out the information or data daily, day wise. We find out that this type of things. Also you can see some data set. We find out the monthly or annually. Okay, it provides a lot of data. You can see lot of data. And MODIS, it's provide the different types of resolution. In this time we are just work with the Landsat. Okay, if you check the information also, let me show you that for the Landsat, suppose Landsat 9, you can check the all of information from this dataset information. You can see this is the Landsat resolution, pixel size 30 meters. Okay, this is the repeat time 16 days. Okay, we also get this, and this is the available time. Okay, for the Landsat 9. So now if you check suppose MODIS, the same, we also find out this type of information for the different types of product. Suppose you can see there's a lot of product we can find out, and all of are the same process. So you also try to read this type of description, then you can get the idea which data provide you which information. okay, because it's very important. Which data which give you the which information. Suppose you can see this is the data, it provides the leap area index, okay, and how we can easily use the leap area index for the remote different types of remote sensing analysis. We are use the leap area index. So for that you need to read some scientific paper how to use leap area index, how to monitor the crop health. So these type of things you also try to charts, then you can get the more better study all of data. And also the replication, you can see this is the aerosol optical depth, okay, this is the one kind of ready-made product, mainly dust, okay, we can easily identify where is the high dust, where is the low dust, and we can also identify dust storm, okay, this type of place using the data. Also you can see the albedo data. Also you can see different types of data, sono data, land use land cover data, okay. Also you can see the land surface temperature data, LST, okay, it's the daily global, we find out the data. Also you can see the land surface temperature 8-day average data, mainly 8 days interval data. This is the vegetation indices data, 16-day global 500 meter resolution. This is the data vegetation indices 60-day 1 kilometer resolution. Okay, you can see the lot of data. So this type of data how I can use, okay. So all of data are the same process, just I will show you the one data, but you also try for the other data, okay, how to work. You can see the fire data, fire daily data, okay, a lot of data we find out. Terra leaf area index, evapotranspiration data, okay, net evapotranspiration data. So you also try to use this type of data for the different types of research. We also use this type of data and similar process when you work. So I'll show you the one data set, you try to work for the other data set, similar process, okay. Suppose I want to work with this data. So this is the Terra vegetation indices 60-day global 250 meter resolution. So this is the one kind of data. So this data, just I click on here, then I can get all of information about this data. So this data available between 2000 to 2025, 1st November, last time period, 1st November. And this is the dataset provider. And when you click this link, we can get the more information about the dataset provider. This is the same way, it's a snippet ID or directory of this dataset. And you can see the 16 days and pixel size 250 meters, okay, pixel size 250 meters. And it's one kind of ready-made data, mainly ready-made product. So we find out this is the NDVI and EVI we find out, okay. NDVI basically normalized difference vegetation index, EVI basically enhanced vegetation index we find out. So this data set is ready-made product, we find out the NDVI and EVI from this data set. Two types of product we find out. So I want to suppose work with the NDVI. Sometime EVI is also important. So we can also try to read this type of paper. Suppose just to show you that NDVI, simply search from where we can get the USGS website. So you also try to read this type of thing, then you can get the more better idea how to use NDVI and what is the NDVI, okay. So this is the NDVI you can see. And we can also compute the NDVI also Landsat or Sentinel-2 to discuss about that. So you can to compute the NDVI, okay, this type of formula we need to compute for Landsat 8 and 9, okay. And what is the NDVI? So this type of thing we get from here, mainly theory part, okay. But in this time Modis product, okay, Modis provide you a ready-made product of NDVI. So when I am using this data, I don't need any kinds of correction. Suppose cloud or noisy pixel, don't need to correction because it's a ready-made product. And if you read the description, so you can see it already marked for water, cloud, heavy aerosol and cloud shadow. So this type of unnecessary pixel is already marked out from the imagery. So that's why when you are using this data, we find out the very neat and clean NDVI information, okay, not need any kinds of filtering image properties. Sorry. And if you check in the this type of ready-made data, there is no image properties information. You can see description, bands, term of use, citation and device, but there is no image properties. There is no image properties, okay. There is no image properties we find out in here, okay. But Landsat Sentinel, okay, we find out the image properties, but in this time it's a ready-made product, so not need to filtering any image properties or image metadata, not need to filtering, it's already filtered. Water, cloud, heavy aerosol already filtered, and cloud shadow already removed from this image, and create this type of information, NDVI and EVI, and it's globally available. Okay, so let's go try to use it, and then further we try to create the NDVI map. Okay, and NDVI basically it's indicating about the vegetation. Okay, vegetation density, or where is the high vegetation, where is the low vegetation, or where there is no vegetation. So this type of things we can get from the NDVI. So same, just copy the snippet ID from here, just copy and open a new code editor. And then paste, just paste in this code editor. Okay, so now give a variable name. I put the name, suppose dataset equal. So now this is my image collection, and in this image collection have two bands. If you check, we find out the NDVI and EVI. I want to work with suppose NDVI. Okay, so just copy the band name and then use the select function and paste the band name. Okay, NDVI, and I want to compute the NDVI for a specific time. So put the filter date function, 2025 1st January from 2025 November 1st. Right? And now I want to check how many images I find out. So if you check, just print the data set and use the size function. So now it's computing how many images, 19 images we find out that. Okay, 19 images we find out. And if, okay, let me show you that for the full one year, suppose 2024 to 2024 December. So I take the annual, December suppose 31. So now let's check. We find out that how many images? 23 images. So 1 year we find out that 23 images. Okay, 23 images. And if you check the image revisit, we find out that the 16 days interval. Okay, image interval is 16 days. 16 days. Okay, so 16 into 23, if you check 16 into 23, we find out the almost 1 year, 368 days information. So for the 1 year we find out the 23 images, because this is the interval is the 16 days. Okay, 16 days we find out in here. So now I want to create the map easily. If you check, just I put the map.add layer for the globally data set and run the code. So now it's added the layer for the whole world. Okay, it's add the image in year of 2024. There is no color, so I want to add the color to identify vegetation, or where is the high vegetation, low vegetation. So we can easily get the information. You can check the some information about the color code. So this is the color code. I simply copy, just take copy and then paste here. So in the color code, basically they are put the range, NDVI minimum maximum range, and also create the list. In the list they add some color hexacode. Just I copy the visualization parameter and paste after the data set. So now run the code. So now it's added the color. If you check, we find out this type of NDVI map. Okay, so basically this type of, there is no vegetation, it is snow or ice. This type of green, this there is no vegetation, this type of place. Okay, this vegetation we find out. Okay, so this is the whole world NDVI map we find out, look like that. In 2024 we find out. Okay, but now I don't need for the whole world. Suppose I need for a specific country, a specific boundary, a specific shapefile, a specific polygon. So how I can work for that? So just simply import the shapefile, or simply import the geometry, Suppose I simply choose US DOS and I choose the international country boundary polygon. Just it started the table, so I want to filter and choose my specific boundary. So take a variable, suppose RY, this table I want to filter earth engine dot filter dot equal what's equal what, put the country name. I choose the country name, suppose Bangladesh. So now what happened, you can see just I simply stored the Bangladesh country boundary shapefile in the ROI. So I need the data, I need the map for Bangladesh boundary. So for that, if you check, when I just put the clip function and clip with ROI, just run the code, it show a problem. It show this type of problem. Clip is not a function. With similar things, same concept. So clip, this function, it's only work for image data type. Okay, this function is only work for the image data type. So now it's an image collection. Okay, so you can see this data set is the image collection, and how many images in this collection? We find out that total 23 images in this collection. So this collection, when I just use the clip function, so it show this type of problem. Clip is not a function because clip is only work for the image data type. So now when I work with for the specific boundary, I need to reduce this image collection. Suppose I have total 23 images. I want to compute the average of 23 images pixel value and then calculate the average NDVI map for my Bangladesh boundary in year of 2024. So for that, we just take a variable. So I'll take a variable, suppose I take a variable, suppose average NDVI. And now I call the data set because it is stored total 23 images. This 23 images, I just compute the mean or average ROI. So now further, I want to just use this average NDVI and I want to add the layer and run the code. It just add the layer for only for Bangladesh boundary. Okay. So now I want to focus my given study area. I want to focus on my given study area. I want to focus my given study area. Suppose map dot center object. Center object is ROI. Zoom level suppose 10 and run the code. So now it directly focus my given study area. We find out this type of NDVI map, but it's some problem on the color. So you can get this type of information for the NDVI. So we find out this type of NDVI map look like that for Bangladesh in year of 2024 annual NDVI map. So not only for that, suppose I want to choose another country, just put the country name. Suppose I put here that Australia and run the code. So now I show you the Australia NDVI map in 2024. Find out. So you find out basically this type of green color indicating about the dense vegetation. Okay, there is no vegetation or barren land, and this type of white color it show the water body. So you find out this type of map. So any country, simply put the country name in here, because this large scale data set is stored at all of country boundary level in the world. So you can simply change the country and check the different result. Suppose I want to put the another one and run the code. So we can get this type of NDVI map in year of 2024. Mainly vegetation information we find out. So this type of place we find out the vegetation. Vegetation or cropland or agricultural land we find out. So it is agricultural land. So any country, simply put the name, then you can get the result. Suppose put here run the code. Yes, please. Yes, please. Any question, please?
I want to find out if I need maybe NDVI map for maybe my country, maybe from 2020 to 2025, for both maybe rainy season and then the dry season. Is it, how do I go about it? Do I go about it maybe year by year? Maybe I do for 2020, 2021,
No,
or
no,
there's a
no,
way to
no,
do.
no, no. We can also use the another function. Suppose how to filtering the rainy season, and also how to filter for wet season for the specific year. So I will try to show you the all of this step by step, inshallah, no problem. Okay, so just is start one by one. So I will try to complete all of those. I can get the idea how to work. Okay, so step by step I just go, because all of participant is very basic this thing, so that's why I'm not showing the all of the complex code at the first time. Okay, so I will try to, inshallah, try to complete all of those, how to filter only for the seasonal or monthly. Then you can get the idea, no problem. You can get the idea, no problem. How we can easily use, so if you simply search here, you can check the, if you simply search here date function, you can see how there are a lot of function for the date filtering. So date, and find out the, you can see the date, you can see ee.date. So there are also date range. So basically ee.date and ee.date range. So this type of function we are use for filtering the different, suppose rainy season, annual season, or a specific time period. Suppose in year of 2024, or suppose 2000 to 2025. Suppose I have the year, it will be start from 2000 up to 2005, but I need the result only for the annual season, all of year only for the annual season, or all of the year only for the rainy season, or dry season, summer season. So this type of things will be completed, inshallah, no problem. You can get the idea. Okay, so step by step I will try to show the example, lot of example, and this type of example you just connect with the other application. Okay, so not, it's just not for that I just show you the code only for this type of code. You can also try to use for the another application. Okay, so I hope you can easily get the idea, this type of things, no problem. And after completing the 7 days training, when you face any problem, then you can simply ask me. I try to support, no problem, inshallah. Okay, so it also possible, no problem. I'll try to show you that. So we find out this type, it's annual. So in this time we find out the annual. You can check. Suppose you can also manually, you can also do it, just change the year, but it also possible use the other function. Then we can easily identify. Suppose from 2000 to 2025 only for the month of January, only for the 2000 to 2025 all of year I need for a specific season, summer season, rainy season. It also possible. I'll try to show you that, no problem. So now we find out this type of NDVI map. Okay, but this map have a problem. If you check the inspector value, click on the value, click on here, it shows, suppose for this coordinate, what's the value of NDVI, and find out. You can check, we find out the value, this type of value 4980. Okay, so it's show very large value, we find out. So it create this one kind of problem. But if you simply search on the Google, suppose simply search NDVI range, then from the website, if you check the USGS website, simply check the NDVI Foundation of Remote Sensing for the phenology. So in these things, if you check, it show the NDVI values range +1 to -1. Okay, +1 to -1. We find out the values range of NDVI pixel value range. And areas of barren rock, sand, or snow usually show very low NDVI values, 0.1 or less. Okay, sparse vegetation, mainly scrub or grassland, we find out the value 0.2 to 0. Basically you can see NDVI, moderate NDVI values 0.2 to 0.5, and high NDVI values we find out that 0.6 to 0.9. Okay, very dense vegetation we find out, and their peak state for the crop at their peak growth stage, we find out the dense vegetation, very high NDVI values. So this type of values, but in this case if you check, we find out it show very high values. It show this type of values, very high values. Okay, so now I need to rescaling our data. Okay, it's very important for rescaling, and how I can make the rescale. So when we make the rescale, then we find out that appropriate NDVI pixel values, otherwise it show this type of very large number. So if you check, this data set have a scale value. They already have the scale value. If you check the scale value, this is the scale value 0.01 to this 0.01. So this is a scale value. So this scale value I need to use. Okay, then I can get the reproject my scale value and get the proper range -1 to +1. So not only for this, when you work any data set in the Google Earth Engine, you try to check this data set have a scale or not. If there is a scale, you must use the scale. Otherwise, you get the wrong pixel value. Okay. So always you try to check a scale column is available or not. Okay. Basically for the modis, we find out the scale, and also Landsat, Sentinel, we find out the scale and offset value. So you always try to check any data set is there scale value is available or not. So in this case, we find out this is the scale is the available. So you must use the scale. Otherwise, it show this type of large number of NDVI pixel values. So how I can use this scale? So if you check how many images, we find out the total 23 images. Okay. So I need to multiply this scale value with all of images. Okay. So then it will be projected all of images. So how I can multiply? If you check in this case, if I just in my collection, if I just use a function, suppose multiply, and multiply with the value 0.001 and run the code, it show a problem. Okay, because this multiply function is only work for image data type. If you check the data like function, so let's check why is the function image. So if you check in the image, we find out the multiply function. Where is it? Multiply function, okay, in the image section. But now this data set is not the image, it's just a image collection. Okay, so it also possible, if you want, you can just simply apply here, because it's a image. When I apply the mean, then it's a image. Okay, so then I can easily apply the multiply function in here. If you check, just I put the multiply with 0.0001 and run the code, then it will work. There is no problem. But how I can connect the collection? Suppose I want to multiply all of images. I have total 23 images. This 23 images, all of images, every single image I want to multiply with this value. So for that, how I can do it? So for that, we need to create a function. We need to create a tool. So this tool help you to multiply all of images 0.001, this is scale value. So now we try to already discuss about the function concept. This same concept we also use in here. So we create a function, okay, and just use this function. Okay, so these things we need, because when you work with the time series analysis, okay, time series analysis, we need the every image's value. Okay, suppose I want to make the NDVI time series chart. Okay, it also okay, you can see there is no problem when I multiply with that. But when you work with the time series analysis, suppose for the every single day, what's the average NDVI value for my study area, I want to check it. So for that, we need to calculate every single images. We need to multiply with the scale factor. Otherwise, it's not work. Okay. So for the time series analysis, it's very important. Suppose further, you also use the lot of application for the different time series analysis. So same. So now I need to compute all of images multiply with this value 0.001. But when I just connect with my collection, this is my collection, it show a problem. It show this type of problem. Okay, this multiply is not a function. We find out this type of problem. So now how I can multiply all of images? Okay, so now we try to apply here. Suppose we create a function. This function help you to multiply all the images. Okay, So we already know about that. Before the function, create a function variable name. I put the function variable name, suppose rescaled ndvi. Okay, and now create the function keyword. Okay, now put the element. So in this case, I have total 23 images. Okay, so if you want, you can also put the total 23 elements. Suppose image 1, image 2, image 3. Okay, it's not the proper way. So it, suppose I have the total 1000 element or 500 element, very large number of elements, then I face this type of problem. I need to create a lot of elements. I need to need when I have, but in this case we are just take only for the one element. I just take only for the one element. Suppose this is my one image, and further put the curly bracket. This curly bracket, I need to put my argument. What is my argument? My argument is that this element I want to multiply. So I just put the return function, return this element, multiply with 0.001 or 01. Okay, let me check the values again. So 0.001, yeah, 0.0. Okay, so now you can check. Just I take the one element and I just return this element, multiply, just work only for the one image or one element, but I have rest of other images. Okay, so for that, what can I do? So for that, we simply use another function. It's called the copy properties. Okay, so just I copy these properties. After multiply, I just copy the properties of this element, and this element, this copy properties of this element, I just apply all of images which are available between this time period. Okay, between this time period, and this thing we simply mention in here, system time start to system time end. So now what happened, you can see. First of all, I simply take a variable, create a function, I put the element name, and what is my argument? This element I return multiply with this value, and after multiply it, just I copy these properties of this element and apply system time start to system time end, which is indicating this time period. Okay, it's indicating this time period. So now this is the function, and this is a collection, image collection. So now this function I need to apply in this collection. So how I can apply? So for that, just copy the data set and paste here. And for connecting, just use the map function for connecting. So now what happened? So this is my function and this is my collection. Okay, 23 image collection. So one by one image just come in this function and multiply. Suppose first image, second image, third image, up to all of images just come in this function and multiply with these values. And now if you check how many images we find out in this, we find out the same number of images. Print rescaled ndvi and use the size function. Please any question, please? Yes, any question?
Sorry, my mic was off. So
Yeah.
can't we just copy and paste the dates from above instead of the first system and time?
Yes, so system time instead. So basically this full code, we have a system. So in this system, we already define the start date and end date. Okay, so basically start date
If
and
we just copy and paste these dates.
no, because copy properties we need to apply the system time start. So it's a syntax we need to use. It's a syntax, and it's indicating the first date, it's indicating about the end date, and between this time to find out the 23 images. So you can see after we also get the same number of images, but what's the difference between the two images? So first image collection without rescale, second image collection rescaling the pixel value for ndvi. So now further Suppose don't need, just I remove these things and I compute the mean or average from this new data set. Just I copy and then paste here. So now run the code, we can get the same result. Yes, please.
I wanted to find out whether the rescaling, are you trying to convert those big numbers into positive one and minus one?
Yes. Yes. So basically NDVI range always -1 to +1. And this data set basically create for the globally. But when you work with the regionally, then we need to multiply or rescaling the data to get the proper pixel value of NDVI. Okay. So now if you check, just I click, it show the proper range. We find out the proper range 0.1. You can see mainly between the range -1 to +1, but it show this type of color because we need to also change the visualization parameter also. Suppose I put the -1 to +1, this type of things, and run the code. So now it show this type of color. Further I can also put the more changes, it show this type of color, okay, which is not relevant. So just I click on here and I just stretch the data, and when I stretch the data, it create me the range. So this range I want to use, suppose just minimum range I put in here, and also copy the maximum range and paste in here. And I also put my own color combination, just I remove all of color and I put, suppose in here I put here suppose blue color, and then I put suppose white color. You can put different types of color, then suppose green color. Okay, now run the code. So now green is indicating about the vegetation. This type of green is the vegetation we find out. You can see this type of place is the green, we find out the vegetation. And now if you check the values, just click on here. So now we find out this, for this we can find out this type of values, and dense vegetation find out the high values of NDVI 0.5. okay, so this is the NDVI map. Further you can also export it and get the more better map using the ArcMap or QGIS software for the map layout for what is a paper or presentation. Okay, so this thing also discuss in the fifth number days inshallah, how we can work with downloading this type of data. So now it is try to discuss about the export. Okay, okay, before that we simply make the break for 10 minutes, then we'll start again. Okay, just make a break for 10 minutes. Okay, welcome back. Can you hear me?